Okay, exponential functions, they're either going to grow or they're going to get smaller or decay. So we have things like growth and decay. And things that deal with growth and decay are pretty simple. Like we talk about bank accounts and things like that, those grow, okay, exponentially. Decay is something like half lives, okay? It's more of a biology kind of thing. But the main thing is that these things can't get bigger than infinity. They can't get smaller than zero. So when we talk about growth, growth has to start somewhere, but it cannot be zero. Okay? It's going to go and approach infinity, but it's not going to cross this line here. It's not going to cross the x-axis. Decay is very similar. Decay is going to go down and approach this x-axis, but it's never going to touch it. Okay, and that's called an asymptote. Okay, an asymptote is some. I didn't cuss at you, just so you know. An asymptote. Say it with me. Asymptote is something that it's going to approach. This graph's going to approach, but it's just never going to cross it. Okay, and so when we're talking about growth and decay, things are going to grow and things are going to decay, but they're going to approach an asymptote, which is the x-axis. Okay? What I really want to go over real quick is just, I want to show you the formulas for those. So here's the formulas for growth and decay. Okay, exponential growth occurs when a quantity increases, okay, at the same rate over a period of time. And exponential decay occurs when a quantity decreases. Decreases, but it's never going to be smaller than zero. And so when we take a look at like things like this, exponential growth is this form right here. Y equals a parentheses 1 plus r raised to the t power. Okay, a has to be bigger than 0, so a has to be positive. And this tells you what each of these represent. Okay, where y represents the final amount, a is going to represent the original amount, r is going to represent the rate, okay, as a decimal. Okay, so it's a percent. It's going to be written as a decimal. And then t, it represents the time that this thing takes. And that's how it is for both. And if you notice, the only difference between exponential growth and decay is this little minus sign. Okay? And so that's just the introduction to exponential growth and decay. I just wanted to kind of go over those forms with you.